Hi, this is Mike Hendrickson from Software Architecture in London. I'm here with Duncan from Lightbend. Duncan, how you doing?
I'm doing well, thank you.
So you're with Lightbend. Lightbend's been known and associated with Reactive a lot. Can you unpack all the different components of Reactive?
Yeah, sure. Reactive is probably the key word that we're associated with. And one of the challenges, I think, behind the word reactive is that it's a fairly broad term, and it can mean different things to different people. So from our perspective, reactive has a distinct meaning, specifically allocated towards reactive architectures or reactive design. I think the other meaning that folks associate with it is the notion of something called reactive programming. Mm-hmm. So reactive programming, as opposed to something like imperative programming, just as an example, you would have maybe an equation like A equals B plus C. And as time progresses, B and C change, but A does not. In a reactive programming model, A would change. As B and C were updated, that update would be propagated to A. And that's an important piece of the puzzle. So we look at reactive programming as one of the methodologies or pieces of the puzzle for reactive as a broader term.
And then can you move that up the stack to the reactive architecture? What changes in that model?
Sure. I think one of the best ways to take a look at it is by analogy. If you take a look at perhaps a team, an athletic team, whatever the team is, baseball, football, basketball, you can have a team comprised of fantastic athletes. They could be in fantastic physical shape, their cardio is great, and their actual skill at perhaps shooting the ball or kicking the ball is really good. And so I would kind of equate those to being a reactive program or a reactive function, if you will. There's something that occurs, however, when they come together and they coalesce as a team. There's many examples where you have a team of fantastic players, but the team in and of itself doesn't operate very well.
And loses to the inferior team
and
that
loses
plays together.
Exactly, loses to the inferior team. And generally that's because of coaching or maybe the attitudes of the individual players or so forth. The difference, I think, is that when you move into the area of a reactive architecture or a team that is successful, a transformation occurs. In other words, the aggregate is not the sum of the parts. The team in and of itself, or the architecture in and of itself, evolves, and it exhibits a feature or the ability to some degree of being proactive. Mm-hmm. In other words, the individual team players can not really read each other's minds, but they've trained together for so long, they've worked together so well that they know how to react in the moment of now in association with the other team members. And I think that's the difference, or the primary difference, between just a simple reactive programming solution and a reactive architecture. The architecture in and of itself has to provide the tools so that you can program reactively, but when it coalesces together as a single unit, it has to present, or it has to give the ability to proactively manage its surroundings by being able to react to whatever is occurring now. And in our world, that's being resilient and being elastic, automatically scalable, yeah. And resilience, not just fault tolerance, but being able to self-heal. So
right, so self-healing and reactive, and does AI have any help in this new reactive model?
That's an excellent question. So AI in the sense of machine learning or fast data analytics. I come from the energy industry, and one of the things that we reactively/proactively managed was energy type grids. And all those types of systems are the same. They're distributed systems, and you can think of a transformer or whatever as a microservice or as a node. And what you need to do is you need to keep harmony in how that entire thing operates as a system. It's when a spike in energy occurs, you get an oscillation, and that blows out a transformer. It's like a server going down. So the idea is that each individual transformer, i.e. microservice, has to be able to react not only to its environment, but also to the system as a whole. And then what you layer in is AI or fast data analytics.
For predictive?
For predictive analysis, exactly. So what that allows you to do is that even though each microservice is very baked into its DNA, this notion of reactive, you are now able to optimize that ability because you're able to predict the future within some delta of error and give it more information. Based on historical analysis and some transformation of algorithms, you believe that the future is going to be X, and so you can begin to prepare for it. So another example I like to use is, you are going out in the woods or camping or something, and you have the appropriate equipment for rain, snow, and sleet, hail, all that kind of stuff. However, it would be nice if you could kind of optimize it, and you would know that it's going to rain, so I don't need a heavier coat, even though the heavier coats will do both.
It's not freezing.
It's not freezing, right? So you can perform more efficiently and less costly.
So in today's world, when someone thinks about the architecture that their company is trying to build for delivering software, to their customers, how do they think reactively? How do they think about the architecture that they need to build rather than the one that they have? What are the first things that they do to build that reactive architecture?
I think that in and of itself is one of the major challenges, because the shift that you see a lot of companies making in today's world is they used to be some type of retailer or service provider or et cetera, and now they're rethinking, what am I? And they're redefining themselves as, say, a technology company that happens to provide banking services, or a technology company that happens to provide...
Every company's a software company.
Exactly. Every company's a software company. So the challenge becomes, in order to break through that barrier, it's a philosophical way of thinking about what I am as a company. And that's I think that's really where the challenge lies. For the developer or the engineer, the architect, so forth, for them it's a learning process. They've been trained to think one way. They're thinking more monolithic or whatever over the last 20 years. And now embracing a new approach. I think the first thing that an architect has to accept, when I used to interview people, I said, if you're going to come, or somebody would ask me, can I get into comp sci? I said, the one thing that you have to accept is you'll be in school forever.
Yeah.
And if you don't accept
Lifelong
that,
learning.
you shouldn't, because this industry moves so fast, and it requires a lot of effort. It's a lot of sacrifice to stay on top of things. So it's something you have to desire to do.
So let me ask you this then. So what is the second thing a company does? Let's say a company knows what they want to do. They want to, from a banking company to a services-oriented company, and they're going to have APIs everywhere, and they're going to do everything that they can to really be a service-first company. What's the second thing they do when they're thinking about their architecture of software development? I mean, is there some secret sauce for success versus people who just give it the good old try but it doesn't work? Sure,
yeah. I would say that the first thing, and I actually went through this caterpillar to moth genesis in my previous company, I realized that the way that we designed systems at the time was not going to be able to handle the volume of data that we were going to process. There was just no way. I'd seen it crash. I'd seen it had all kinds of problems. The problem was I didn't really know how to solve the problem. And as I began to do the research and understand, I realized that distributed computing, and from our perspective at Lightbend, that's what we're talking about when we talk about reactive. Distributed computing was the solution. Now, which distributed computing model and all that had yet to be figured out at the time. But I knew there were some things about distributed computing that were markedly different from the traditional, more monolithic style. One of them is, for example, the domain model. It's the way that you design the domain model is influenced heavily by the fact that you're a distributed architecture. And things like immutability become incredibly important, whereas they're not so important in a monolithic style architecture. So the first thing, I think, or the key thing is recognizing the fact that it's not just Google and Amazon and Netflix that need distributed systems, that your average company now of medium size or even smaller, if they want to be competitive, they're going to embrace that mentality. And once they do that, then they can begin to take a look at where they want to go. If they're on the JVM, Lightbend is the choice, in my opinion, obviously. But and as a customer prior to joining the company, I did that same research and looked at the same things and realized that the solutions that we offer were the best choice. So that's what I would say would be kind of like the evolution, the journey.
Yeah. So if you fast forward 12 months, and let's say we sit down here in London next year, what would you like to say Lightbend is doing differently in this space, in specifically architecture and reactive architectures? What would you like to say you're doing differently, and what should the industry be doing differently?
So I think two primary areas is obviously continue honing and tuning the toolkits that we have and providing the feature set that we have. one of the things I like that we do is we listen to the customer, and then we weigh what the customer's asking for to see if it makes sense with the direction that we're headed in. And I think the toolkit that we have out there now is essentially focused in that direction and does a good job, and will continue to, just optimize it. Things like ACA cluster sharding, and all those types of things in play. I think that is one big part. It works well. It just works. That's what we all used to say about ACA. We use it because it just works. Then I think the other area is the data analytics. Having been in the energy industry and doing a fair amount of that, to predict, because it was tied to the energy market where you could make money. You make money by either saving it, not spending it, or earning it, right? Individual companies would allow their generator to be used to supply energy to the grid or whatever.
Unlike Uber, energy doesn't surge price, do they?
That's a good question.
Yeah.
Now, the energy market is an interesting beast. But so in order to be successful there, there's also incentives and so forth. And for example, in the energy market, if you're on peak load days, if you were to not exceed a particular value, the general company that ran the 5-state area you could make hundreds of thousands of dollars. And so, but you had to predict what your load would be or when those days would be. And I think that's where we're going to begin to offer some real value is the notion of being able to do predictive analytics in a timely fashion. The historical problem with that is that it takes too long. Like I can tell you what the temperature was yesterday with 100% accuracy. And I think as time goes on, hardware gets better, the software algorithms get better, things like Spark and the things that we're working on are more efficient, and streaming of data, so forth. You're going to be able to get answers and answer questions about what the future could be, and then kind of prepare yourself for it programmatically.
Excellent. Duncan, we look forward to that conversation. Thank you.
Thank you. It was nice meeting you.